So this is the remediation for advanced factoring, which is our newer kind of factoring, and we do have a new flowchart for this that has more exciting things to look at. So remember, top of the flowchart is always looking for common factors. So when I look at this polynomial, I notice that there's a common factor of 3 that we could take out. So this is going to be done in 2 steps, so keep your eye on that. So this becomes a trinomial of x squared plus 3x, and let's see, that would be a minus 40. So I start thinking about a trinomial factoring pattern is that reverse foiling pattern. So you're looking for numbers that multiply to negative 40, but I need your arches to add up to 3. So you might want to mess around with some numbers that multiply to 40, but notice your signs. One has to be positive and one has to be negative to give you a negative 40 product. 40 has some options, right? Like 8 and 5, 10 and 4. There's a lot of options, but I'm going to stop because I think I found my winner. If I use a positive 8 and a negative 5, those arches would add up to 3x in the middle, which is exactly what you need. So those add up to 3x. Life is good. So again, this is a factoring question where you do have to do this in 2 steps. So you cannot convince me that you are going to be factoring this in 1 step. I'm going to assume that you copied the key. Don't do that. All right, moving along. Let's take a look at number 3 down here. Common factor again that you're going to take out. I notice that we have a common factor of 2. So factoring out the common factor of 2 from your polynomial, it's going to leave you with the binomial of 4r to the 4th. And then a minus 9. So that binomial follows the pattern for difference of 2 squares. So it's a little unusual because we do have the higher power. The 2 stays out in front. And then the way the difference of squares pattern works is you find the twin factors for the 4r to the 4th and for the 9. So twin factors for 4r to the 4th would be 2r squared and 2r squared. And then the twin factors for the 9 would be 3 and 3. And then the way the signs work is 1 positive and 1 negative. Now, because of our advanced factoring that we've been learning, you do have to be wary about further factoring. Sometimes this other difference of squares sometimes will factor more. Like if this said we factored one and it was like r squared minus 9, then you'd have to factor it again. So watch out for that. That does show up on this remediation somewhere. Alright, some more advanced factoring that we talked about. My gosh, my slides are not moving around. Just a moment. Nothing's working right today. There we go. We have that cubic pattern. So you do get to use the factoring flowchart. This is the sum of 2 cubes. And the way the sum of 2 cubes pattern works out is that it starts off with what looks like this, a to the 3rd plus b to the 3rd. And your job is to rewrite it into the pattern, which is the factoring pattern. It's a plus b times a squared minus ab plus b squared. So I always encourage you guys to write out the factoring pattern on your paper before you start the problem. And then let's talk about who a and b are. So remember, this is a cubed, which means if you were to cube root both of those, a would just be a 2. And then this is b cubed. So that means your b value, if you cube rooted that, would just be an x. Now because this is a sum problem, you have the commutative property, meaning you could rearrange the order. So keep that in mind. But if I keep this exactly in this order, the a is a 2, so 2 plus x. And then a squared would be 2 times 2, so 4. And then you're going to subtract a times b, so subtract 2x, and then add b squared, so x squared would be the last term. What I like about the cubic pattern is that once you use it, you are done. There's never going to be any further factoring. In this remediation page, you're going to see some comparable cubic pattern factoring ones. I don't want to do any more for you because there's only, I think, 1 more on your paper. Alright, the last kind is when you have 4 terms like this, you're going to factor by grouping. So, I know this is a grouping question because it's a 4-term polynomial without any more simplification. So what you do is you group the first 2 terms together, and then you group the last 2 terms together. And they create their own little common factor questions. So in this first group, the common factor that we could take out of that would be, there's no numbers, but we could take out an a squared. So if you factor out an a squared from that first group, think about dividing this and this by a squared, you still have a 7a and a minus 2. Now in the second group, there's really nothing common to factor out, so you have to factor something out, and you can always factor a positive 1 out of a term, and it's not going to change the value at all. So that leaves you, if you divide by 1, you don't change it, so it's a 7a minus 2. And this is how I know we're on the right track. You should now have a common factor in the parentheses that you're going to take out to the front of the problem. So the 7a minus 2 can come out in front. And then if you look at, okay, what do I have left over when I take those out of the problem, I still have an a squared and a plus 1. This is another case where you guys got to be real paranoid that sometimes there's further factoring. Once in a while, you'll have another step of factoring on these questions after you do the common factors. So watch out for that. All right, complete this remediation page, come in for help, and maybe rewatch the original lesson on advanced factoring if you need to, and then you can turn that all in and come do a retake. Good luck.